Sorry, I don't know why I can't use my Apple Pen to make some of the mark there. So I will try to give you some of the hint just by the description. Is that okay? So yeah, let's try it right now. So you see here, we have the marginal productivity of the shoes, right? So shoes and wine are two goods in this model, and I have two countries here, which is Italy and France. So the first step to figure out the Ricardian model is to draw the production possibility frontier, right? The production possibility frontier. In order to draw the production possibility frontier for two countries, what conditions we need to know? The MPL. MPL stand for marginal product of the labor, right? So what's the meaning of the marginal product of the labor? Means if I hire additional 1 hour of the labor, right? Or I hire additional unit of the labor, how much production they make. So in this case, pair of shoes produced per hour are supposed to be what? Supposed to be the MPL of the shoes in Italy, right? Delia, is this make sense? Does this make sense?
Yes, it does.
Okay. And then for another goods, it's called wine, right? So what's the MPL in wine in Italy? MPL in wine in Italy, that's equal to 4, right? And then in France, it's the same case. So MPL in France, it's 3. In shoes in France is 3. MPL of wine in France is 2. So based on this information, can you draw out the PPF?
Yes.
Could you?
Yes.
We usually need one more condition. That's the labor endowment or the population of that country, right? But here we don't, so we could basically just assume it, right? So you could assume Italy has like 10 labors, or like it's like 10 hours of for hire, and France has 10 units of labor too. So that if I want to draw the PPF in Italy, I need to use a graph with the vertical axis and horizontal axis, and they represent each of goods maximum production, right? So the intercept is the maximum production. Let me use. Can you guys just open up this file on your computer so that I can use the Blackboard. I can use a whiteboard to give you an idea, because I feel like this is really hard if I didn't draw all the graph. I'll stop sharing, and then you should pull up this document. Go over one more time with you.
Okay.
Okay, so shoes, right? So the conditions now I have is shoes, and this is the wine, in two countries, Italy, France, right? And I know the MPLs in shoes in Italy is 6. MPL in wine in Italy is 4. MPL in France for the shoes is equal to 3. Wine is equal to 2. Okay, so the first step to figure out the Ricardian model, remember that Ricardian model is the second model that we encounter in this course, right? So it's the first one, the first neoclassical model. So it's a two country, two goods, but only with one production factor, which is labor, right? So based on this, we need to assume, if you want to draw the PPF, we could assume that the labor endowment in the Italy is equal to 10. In France, is equal to 10. Okay? So this is my production possibility frontier graph. Right? So the layout is like this. And you could choose either you put shoes on the horizontal axis, or you could put shoes in the vertical axis, doesn't matter. And wine is here. Right? If you choose like this. So what's the next step? We know this is the first characteristic in the Ricardian model. What about the second one? We know the PPF is a straight line. No diminishing return. Very good. Yeah, exactly. No diminishing return. It's because only focus on one production factor. There's only one input in our production. So if I assume Italy's population is 10 or labor endowment is 10, what is the maximum number of the shoes that they produce? So remember that PPF is a bundle of the production goods, right? So now I have two production goods, which are shoes and wine. Exactly, Mel, thank you for your answer. So the maximum goods, the maximum shoes that Italy can produce are going to be equal to 6 times 10, that's equal to 60, right? So if that is the case, just draw interval here. This will be one of your intercept. What is the meaning of this? What is the meaning of this point? At this point, Italy produced 60 units of the shoes, 60 pairs of the shoes, and 0 bottle of wine. By the same token, what about the intercept on the y-axis? Y-axis. So that's just on the flip side, right? If you put all the labor into the wine industry, how much wine would you produce? 40, right? And that's calculated by 4 times 10. So this point are going to be 0 and 40, right? So what's this mean? 0 means 0 pair of the shoes and 40 bottle of the wines. And based on our assumption, no diminishing return to scale or constant return to scale in Ricardian model, we know that PPF are going to be a straight line. So you connect those 2 points, you could find out this is your PPF. So what's the next step? To draw the PPF for the friends as well, right? So I won't repeat it right now. What about the slope? To identify the trade pattern, we need to take a look of the opportunity cost of producing one good, right? So what's the meaning of the opportunity cost for producing one good? For example, here, what's the opportunity cost for producing one pair of shoes in Italy in terms of the wine? So we need to take a look of the slope of this straight line, right? So what's the mathematical representation of the slope? The mathematical representation of the slope is the rise over the run. Exactly. So here, the rise are equal to 40, and the run is equal to 60, right? But remember that because this is a negative slope line, so mathematically you should write like this. So what does this mean? This means if you want to produce additional pair of the shoes, how much bottle of the wine you have to give up in Italy, right? And this is also the meaning of the opportunity cost of producing a pair of the shoes in Italy. Right? So slope actually means a lot. Slope could be opportunity cost, could be the ratio between the marginal productivity of a labor of two goods. And furthermore, we know the slope is actually represent the relative price of two goods, right? So how do we decide? How do we figure out which one have the comparative advantage in producing? For example, here it's shoes. So you find a square number of the slope, right? So for example, here you see in Italy the slope is -2/3, and if you do the same thing in French, you will find out. You put shoes in x-axis and y in a y-axis. You find out the slope. It's also equal to this. So which one is higher? That is a question. Which one is higher? They are the same, right? So based on the Ricardian model, based on the Ricardian trade theory, could any of them trade with each other? Or can we say like any of the country benefit with each other? No. So that's supposed to be the answer for this one. Okay, so this is something you have to feel very, very comfortable with right now, starting at this point, because every model that we talk about, except for the gravity model, the specific factor model, and the Heckscher-Ohlin model, they are all based on the framework of the two-country model. So Ricardian model would be like the base of all the neoclassical trade theory. You have to understand it in and out totally. Okay? So it turned out to be what? It turned out to be Italy and France who has the absolute advantage. So how do we determine the absolute advantage? You simply just compare their. That is the answer for the comparative advantage, Emily. So the one I just demonstrated.
But just wine, but just for the wine, not for shoes.
for so comparative advantage is it's actually, well, yes, if but if you think about that, for the y, it's just the slope is just really difficult. If you put y in the x-axis and shoe in the y-axis, what happened? The PPF slope will be negative 3/2 instead of negative 2/3. And in France, this number will still hold. So the opportunity cost for producing one bottle of the wine is, in Italy, is 1.5 pair of the shoes. That means in order to produce additional bottle of the wine, you have to give up 1.5 bottle. Sorry, in order to produce additional bottle of the wine in Italy, you have to give up producing 1.5 pair of the shoes.
I just mean on the homework it asks us which country has the absolute advantage and comparative advantage for shoes and wines. So how do we calculate that?
And so for the absolute advantage, you just simply compare the marginal productivity of the labor. So for here, who has the absolute comparative advantage in shoes? Just simply because Italy's labor productivity is higher. So that means Italy has the absolute advantage in producing shoes. And so it's the same thing for the wine. So in comparative means everything is in ratio. You compare the marginal productivity of the labor in shoes and in wine, and compare the opportunity cost for producing wine or shoes. Does this make sense?
I understand that we just did the wine, we didn't do the shoes. So how do we?
No, we just do. Okay, okay. So for okay, so then let me try. So okay, so the easiest way for answer this question is to switch the x-axis to y-axis. So you put y here, you put y horizontal axis, and you put shoes in the vertical axis, so that you could figure out the opportunity cost in different goods. Now we figure out the opportunity cost for producing additional pair of the shoes in terms of the wine, right? If you want to find out the opportunity cost for producing one bottle of wine in terms of the shoes, you just flip your axis. So shoes become the y-axis, and the wine becomes the x-axis. And by the same token, you can figure out that's equal to negative 3/2. Okay, let me just do it one more time.
How does that answer like question B though? The which country is a comparative advantage?
So in this case, there's no comparative advantage in both of the countries, right? Because the opportunity cost for producing the shoes or producing wine, they are all the same. So based on the Ricardian model's assumption or the prediction of the Ricardian model, no country will involve in the international trade because the comparative advantage, it's not the same. It's the same. But in terms of the absolute advantage, Italy has the absolute advantage simply because both of the goods, their marginal productivity of the labor, it's higher. Okay? Okay? So last part, does Italy gain from trading with France? Briefly explain why or why not. So if they both don't have the comparative advantage, once open up to the trade, will the relative price of the goods change? If two countries, their opportunity cost for producing either of the goods are the same, will they get involved to the international trade? The answer is no, right? The answer is no, because they will still be on the same production possibility frontier. Relative line and the relative price will not change. You won't have something like this or something like this after the trade. So the utility curve, the utility function in different curve, will not have the chance to go up. So there's no gain for both of the countries involving in trade. Okay? Oh, I basically give you the answer for this question. Any other question? This could be found on the chapter 2's lecture slides and could be found on Finstra and Taylor chapter 2. And additional problems relating to the Ricardian model has been posted on the Blackboard with the answer key. So if you want to get some of the practice, you could take a look. Okay, so let's take a look of the next question. That no problem. Yeah, thank you. No problem. Let's take a look of the question of question number 8. So let me just show you. Okay, so this is the question, right? So basically, this is just a repetition of the last example we went over in lecture 4. So that's on last Wednesday, right? So specific factor model, one of the important assumptions is what? Is the labor, it's a common production factor, right? So labor could be used in manufacture and also could be used in agriculture. That's the setting. However, in manufacturing sector, there's another specific production factor that is called capital. And then in agriculture sector, there is another specific production factor that's called land, right? So we try to figure out those two terms. The first one is called rental for capital. So what's the meaning of this one? The rental for capital, actually just the revenue of the capital or the returns of the capital, right? So something the firms has to pay to use the equipment. And the rental for the land, you could just treat it as like a rent if you want to, use a land to grow some of the crops, and you have to pay the rent rent to the landowner, right? And this is all the information we have. We have the sales revenues in both of the sector in manufacture. Also, I have the sales revenue in agricultural sector. And since I only have 2 production inputs, that means if I'm the firms, I only have 2 costs, right? So one is the labor and one is the capital in manufactured sector. And it's the same thing in the agricultural sector. This is my sales, my revenue. This is my pay to the worker who works in the agricultural sector. This is the pay to the land owner, the rent, right? So it's total pay to the landowner for the rent of the land. T means the unit of the land you use. RT means the rent on the land. And then I also told you, question also tells you the percentage decrease in price. The result after the trade is this in manufacture. So the manufactured goods decrease by 10%. And the percentage of the price does the agricultural goods, their percentage of the price does not change. So this is equal to 0%. And one more thing I know is that the wage right now, the change in percentage is -5. So in this scenario, the relative price in manufacture is increase or decrease to the price change in agriculture sector. The price of the manufactured goods is decrease or increase to the in compare with the agricultural goods. Guys, that's a question. Is increase or decrease?
One more time, can you repeat that?
So the price of the manufactured it's increase or decrease in compare with the price of the agricultural goods. Okay, Ryan, decrease, why?
So the agricultural good stays at 0%. There's no change in the price of the agricultural good, but the change in the price of the manufactured is down 10%.
Exactly. Right, so the price of the manufactured goods down and the price of the agricultural goods remain the same. So the manufactured goods is decreasing, right? So the rest of you understand this setting, the rest of the question is just plugging to the formula. So just let me go over a little bit. Hold on a second. So what is the meaning of RK? If you go back to the textbook, RK it's equal to K times PM times QM minus W times LM. All of them are notation, right? So what's the meaning of this equation? And this is the beginning of this question. If you want to solve this question, the total revenue of the manufactured goods, it's here. the price of the manufactured goods times the quantity of the manufactured goods. And that's equal to the payment to the capital plus the payment to labor. Right? I only have two production input. The total revenue for this firm has to separate into the payment to the capital and to the payment to the labor. All right, so if you do the algebra, you put this term, last term, at the right-hand side to the left, you will get this. Right? And K, if you divide it at both sides of the equation, you will get K in the denominator in the left-hand side is equal to RK. Okay? One more thing, because we are interested in figuring out this term. Right? So what's the meaning of this triangle? We call it delta. Right? Delta means the change in the the change in the on the rental to the capital. Right? So we need to modify our equation a little bit to make everything related to the price change. So this one related to the price, right? Because rental on the capital, it's a term of the price. Wage, it will change as well. And price of the goods will change as well. And divided by K, right? So this is times this dot. So from this to this, any question? Put change sign in front of every price vector. That's it. So the change on the rental capitals, it's equal to the change in the price times the quantity, it's the same, minus the change in the wage times the quantity of the labor hire divided by the capital level. If this is no problem, so we need to make this term similar to this one, right? Because this is my goal. I'm going to see what's the percentage change in the rental on capital, percentage change on the rental of the capital, right? So if this one is the change divided by the original level, that means the change in percentage. This is something in economics we always talk about, right? Change in percentage. Okay, so what do we need to do? I need to add RK in the denominator on the right-hand side of the model so that this term will look like this term. But if I add a RK in the denominator, I also need to add RK here. Okay? So now I have this term on my right-hand side. So if I could figure out this, then I could figure out this is equal to what? Right? So our goal becomes this one. Try to figure out the left-hand side. It's equal to what? Okay? Let me know step by step until now any question. I will encourage you to speak out because I can't always check my chat room. So okay.
No questions.
Okay. So thank you. So from until now it's all algebra, right? So RK delta RK is equal to this. Okay, so what's the next step? Try to use some of the information I know in the question, right? So in the question, I know this term. And I also know this term. The total sales, the revenue of the manufactured goods, right? And I also know this term, the change in the wage. And I also know the return, the payment to the labor, right? So just manipulate this term a little bit. Right? So this one should be identical to this one. I could show you the slides, which page, the slides of page of this slides after the derivation. Just follow my derivation right now. And minus the second term. If I want to use the information I have in the question, I need to add those two terms, right? So now I put W in the denominator, I put W in the numerator as well. So now you have all the information you have. Just plug in a number. You have this term, you have this term, you have this term, you have this term, and you also have this term. And you should be able to figure out what's the change rate on the rental of the capital. And it's by the same token. You should be able to find out this. After you find out those two terms, you should be able to compare with the change in percentage of the goods. It's using A, right? And the wage. You should be able to order them, order these 5 terms. And should check whether their order fit the logic of the specific factor model. Okay. Okay. So this one looks a little bit complicated, but it's actually not, right? If you take a look of the whole take a look of the textbooks and go over by yourself one more time. So I probably would say the hardest trick is just putting the delta. Like this one, it's not very straightforward, but the rest of them are just the algebra. Okay. Okay, so that's the two questions I got from the student for question number 5 and question number 8. Okay, so I need to move on to the lecture today, otherwise we can't complete it. If you do have a question, feel free to shoot me the email. Okay, and specify like which part you didn't really understand. So we have to go back to the Heck-Shorley model right now. Okay, so let's briefly review a little bit of the Heck-Shorley model. Okay, so this is the third model that we talk about in this fourth, but neoclassical model. This is the third neoclassical model that we talk about, right? We talk about gravity model, and gravity model focus on the distance between the trading pairs of the countries, right? If the country is closer, they're supposed to trade more. That's the gravity model tell us. Or the country's GDP is higher, like their mass is bigger, their force should be bigger. So that's the gravity model. Secondly, we talk about the Ricardian model, which is the first neoclassical trade model we talk about. So the mechanism behind the Ricardian model is the differences in the technology between two countries, right? If we only use labor as our production input, the opportunity cost for producing one of the goods is actually the technology of producing one of the goods. You say this country has a better technology in producing one good, means that country has the smaller opportunity cost in producing that good. Right? And opportunity cost means what? Opportunity cost means, in addition, if you want to produce additional one more unit of good X, how much good Y you have to give up. So by compare the comparative advantage, we could figure out a trade pattern by using Ricardian model. And the graph already showed you, right? The straight line and the relative price become like flatter or become steeper, and the consumption point and the production point become split from each other. Consumption is not equal to the production anymore, so that you will have a trade triangle shows up, and one is the export and one is the import, right? And the second model we talked about, we're using two country, two goods, and maybe three factors, right? So specific factor model, as we said last time, it's a short term, it's a short run model from a short run perspective, because the capital cannot move across the industries, right? Specific factor has its name because either of the sector, the manufacturer or the agriculture, they have their own specific capital. In manufacture, we call that specific factor capital. In agriculture, we call that specific factor land. And because of the specific factor, the trade will be a little bit different. The trade pattern will be a little bit different from the Ricardian model. because now one of the production input is fixed. So that the labor right now, it's not constant return to scale anymore. A labor will encounter the decreasing, diminishing return to scale. Right? If you just fix amount of your land, you hire more and more labor, eventually your labor's marginal productivity will become 0. The first one may be very productive, the second one become less productive than the first one, the third one become less productive than the second one. At the end of the day, your marginal productivity of the labor will become 0. That's the idea of the diminishing return of labor. And that's because I have a specific factor which is fixed. Okay? So that based on that, my PPF is no longer a straight line like we see in the Ricardian model. A PPF right now, it's a concave curve. Right? So it's like a concave curve. This. But the trade mechanism is the same in the Ricardian model. Simply it's because the autarky, the no trade relative price, is different from the relative price in trade. So that the production points and the consumption point in one country will be different. So that the country will produce more goods than he consumes. And that becomes the exporting goods in that country. On the other hand, if they produce less than they consume in that country, they need to import from the other country. That's the specific factor model. And the third neoclassical model that we look here is Heckscher-Ohlin model. So it's basically it's a long-term version, the long-run version of the specific factor model. Because now capital, it's not a specific factor anymore. So both of the industry right now can use the same capital. So you could see this assumption like what? The capital means the money, right? So either in the agriculture or in the manufacture, you don't care about like the land or the equipment they use anymore. Instead, you care about how much money they put into their production process, right? So the capital right now could refer to like real money. And the other production input we assume is the labor. So in Heckscher-Ohlin model, we have two countries, right? So home and foreign. That's always the same. That's the standard setup. And the second one, I have two production factor, which are the capital and labor. And two goods, right? So one is capital intensive and one is relative labor intensive. And the mechanism, the force behind that Heckscher-Ohlin model is what? It tells us that the capital abundant country are going to export the capital intensive good, while the labor abundant country are going to export the labor intensive good. Okay, so basically that's a brief review of whole model that we just talked about. So how do we if you use the graphical analysis, how do we capture the capital abundant or the labor abundant of the country? Remember, in a specific factor model, the two countries' PPF, they have relatively similar shape, right? But in a Heckscher-Ohlin model, if the country is, for example, is labor intensive, and on the horizontal axis, the goods is capital intensive goods, the country's PPF will skew to the horizontal axis. On the other hand, if the foreign is capital abundant country, and the vertical axis represent the labor intensive goods, the PPF of foreign country will look like this. So because their PPF become different shape, so for the labor intensive country, they are more likely to produce more of labor intensive goods. On the other hand, sorry, I don't know why it just showed up the straight line. On the other hand, the capital abundant foreign country will tend to produce more capital intensive goods. So the result of the Heckscher link model tell us the capital abundant country should export the capital intensive goods and import the labor intensive good. While in labor abundant country, they should, yeah, thank you, Peter. While in labor abundant country, the country should export labor intensive goods while importing capital intensive goods. Okay, so just very quickly, this is the review, and it's the second part of our lecture last Wednesday. We talked about the test of the Heckscher link model. So the result of the Heckscher link model I already told you is capital abundant country export the capital intensive good. And Leontief find that this is not the case by using the data of the United States in 1947. So this is what he get. At that time, U.S. supposed to be a capital abundant country in compare with the rest of the world. But however, he found that the importing goods to the United States actually has a larger capital labor ratio. So that's that's exactly contradict the prediction of the Heckscher link model. So that raised a lot of the question that people try to explain it. And we are going to talk about one of the explanations today. So first of all, how do you to identify which country are being a capital abundant or being a labor abundant? So the book tells you, the author tells you, just simply compare their share of the goods to their share of the share of the factor to the world and their share of the GDP to the world. So if its share of the factor, the country's share of the factor is larger than its shares of the world GDP, then we could conclude that the country is abundant in that factor. So if you just replace this factor by labor, if its share of labor exceeds its share of the world GDP, we could conclude that the country is abundant in labor. Okay? If the share is certain factor is less than, so it's on the opposite way, right? So those two bullet points are on the opposite way. It's less than its share of the world GDP, and we could conclude that this country is scarce in that factor. So for example, if I said if one of the countries' share in capital is less than its share of the world GDP, then we could conclude that the country is scarce in capital. Right? And this basically what we are going to do as we see one of the table later on. So as you can see, this is the statistical table that the textbook just showed you, right? So this is the factor endowment, right? So this endowment you could just explain it as a resources in 2013. And different color represent the different country in the world. The pink one represents the United States. The blue one represents China. The yellow one is Japan. The gray one is India. Green one is Germany. So basically, how do we decide? And each of the bar represent different production input, right? For example, production input could be physical capital, or the R&D scientist, or the skilled labor, or less skilled labor, and so on. So how do we determine that this country is abundant in this factor? We just simply compare their proportion of that factor with the GDP proportion, with their share of the GDP. So for example, the US GDP to the world GDP in this one is equal to 60.5%. That means this part is equal to 60.5%. And if I want to know whether US is physical capital abundant, what should I do? I just compare this number with this number. So in this case, is US a physical capital abundant country? The answer is no, right? Because the share of the physical capital is smaller, which is 13.4%, than the GDP share of the US. Let's take a look about a case in China. China's physical capital share is equal to 20.7%. What about its GDP to the world? It's 16.0%. Thank you, Peter. Right? So based on this information, can we conclude that China is a physical capital abundant country? The answer is yes. Yes, just based on this statistics, this table, the information that this table gives us. Right? So if we move on to the other production input, we take a look at the R&D scientists. The U.S. R&D scientists, its portion to the world R&D scientists is equal to 19.5. So we compare this one with which one? With this one, US GDP to the world, right? And you realize this is actually larger than this. So based on this, we could conclude that US is abundant in R&D scientists. Let's take a look at the China in this case. The Chinese R&D scientists, the share of the Chinese R&D scientists to the world R&D scientists is 21.3%. And what is the number that I should refer to compare with? It's 16, and this is because the Chinese GDP, its share to the world GDP is 16, right? So we could conclude that Chinese GDP share, the Chinese R&D scientists, the share of the R&D scientists is larger than its share of the GDP to the world. So China, it's also abundant in R&D scientists. Right? But this does not make very reasonable. You know, if you see more like one thing in the agriculture, the U.S. The share of the U.S. arable land, it's 11.5, which is way lower than its share of the GDP in the world. So, based on our logic before, we say that we could conclude that U.S. is scarce in the arable land. But this is very surprising results, right? Because people believe that the U.S. is supposed to be a big exporter of the agricultural goods to the world. So what's going on? We need to define another thing. It's called effective labor force. So not only we need to focus on only the actual number of the labor force, we need to focus on the productivity of the labor as well. So this is the formula for the effective labor force. The only difference between effective labor force and the actual labor force is times the productivity of the labor. So for example, the farmer in the US, because they have the more state-of-the-art equipment, the machine could help the farmer to grow a big amount of the crops. So the productivity of the farmer in the US is supposed to be much higher than the rest of the world. And in the previous table, we only calculate the actual labor force. Okay, so this is one of the reasons, maybe it's the most important reason that we try to explain the Leontief paradox. Because Heckscher-Ohlin model makes total sense theoretically, but why empirically it doesn't work? So one of the important things is that we didn't take into the skill level of the labor into account, right? The productivity of the labor, it's different across the country. And that is something not in our original Heckscher-Ohlin model. Sorry, not in our empirical test of the Heckscher-Ohlin model, not in the Leontief paper. Okay, so let me just show you a graph that's using the effective labor instead of using the actual labor. So for example, here, the productivity of the R&D scientists, it's different than the actual R&D scientists as well. The difference is the productivity, or you could say the spending per scientist is different from across the country. Right? So instead of using the actual data, we should use the effective way to think about it. And what's the differences between them? The differences between them is whether you can use the spending on that factor, or you can use the productivity. The productivity is actually the spending, right? If the U.S. farmers' productivity is higher, they're supposed to get a higher wage or higher return by growing the same amount of the agricultural goods. So this is what we get after we adjust it. So this is originally we see in previous table, right? But now if you times the spending per scientist, R&D scientist, this is the adjusted one, So what do you see? Originally, you see that U.S. is abundant in R&D scientists. Adjusted effective R&D scientists, U.S. is still abundant in effective scientists. However, in China, if you think about the case of the China, originally, if we only count the number of the R&D scientists, it takes 21.3%. Like the R&D scientists, the number of the R&D scientists in China, it's 21.3% of the world R&D scientists. But after we adjusted, the proportion of the China decreased to 8.1%. So now, in terms of the effective scientists, China is no longer abundant in effective scientists anymore. Instead, we should say that China is scarce in effective scientists. Okay? Another example for adjustment of this to determine like which country is which factor abundant is using the land. Previously, we say that U.S. is scarce in the arable land, which doesn't make a lot of sense. But after we adjusted times the productivity of the lands per acre, the amount, the effective arable land of the U.S. it's larger than its GDP. Right? So now we could say U.S. is abundant in effective arable land. Okay. And this will be the same case when we go back to the labor. Right? So the labor, the actual number is the number of the labor. Effective number is the total wage pay. Right? So if you only see the labor and the number of labor, which is originally published in the Leontief paper, that U.S. are considered to be scarce in labor. But if you consider the wage, the productivity of the U.S. labor, which is much higher than the rest of the world, the wage of the U.S. labor is much higher than the rest of the world's labor, and you put that into consideration, your effective labor terms right now become larger than the share of your GDP in the world. So now we could say that U.S. is abundant in terms of the effective labor. Okay, so this is just one of the explanation of why empirical actual link model, why the Leontief paradox has some of the problem. So you need to adjust the actual data by the productivity of the across the country, and this is just give you a sense of the wage and labor productivity. They are positively correlated with each other. So as you can see from this scatter plot, the country, it's the dots here. Okay, so if you plot this one, like you put each country's data of the labor productivity and the wage, you see that if the country had a higher labor productivity, their relative wage is higher. So it's like a 45-degree line, which means it's a positive correlation between this term and this term. That is the labor productivity and wage. Okay, so let's move on to the last part of the actual link model. Right now, we need to take a look. We need to use numerical way to disentangle the effect of the trade. So after the trade, what happened to the wage, and what happened to the rental on capital in Heck-Shorring model. So what does this graph tell us? So this is a market of the home labor, right? So this is a home country labor market. So every time we draw a diagram in the market, what do we put in the vertical axis? We usually put the price, right? So what's the price in the labor market? The labor market, the price in the labor market means the wage of the labor, right? And remember that in the trade model, everything is in a relative term. So price here, the relative wage, means the ratio between wage and rental on the capital. So what is the horizontal axis that we usually put if we use the equilibrium analysis, supply and demand? It's the quantity, right? And quantity in trade model, it's in relative term as well. So what's the relative term of the two factor? That's the number of the labor divided by capital. Okay? And this one, the vertical line here, is the supply. It's the supply of the labor to the capital. And this is going to be fixed because each country, they have their own endowment, right? And if we're using the mathematical equation to disentangle this L, so L in home country, labor in home country, total labor of the home country, it's equal to the labor in the computer sector plus the labor in the shoe sector. Right? So this is the first equal sign. Simply separate labor, total labor in the home country into two terms. Okay? So what do we have here? We have LC over K bar plus LS over K bar. But this is a little bit hard for us to do analysis. What we need to do a little bit more is the algebraic trick. I need to put the relative labor capital ratio in computer sector. So in order to do so, I need to add a capital in the computer sector in denominator. But by doing so, I need to put another term in the numerator as well. Right? So this will remain the first term I have. Secondly, LS, KS, KS, K bar. That's how we get the second equal sign. All right, so what's the meaning of this one? What's the meaning of it? It means the economic-wise or the national-wise relative demand of labor, it's actually the weight average of the labor capital ratio in two different industries. Right? We already have the supply, which is based on the endowment. We try to construct the demand. demand based on two sector in home country. One is called computer, one is called shoes. And if you separate them, they should have two different labor demand. But if we only take a look at the nationwide labor demand, it's this one. Sorry, I don't know why, it's just Can you guys see it right now? Sorry, my iPad just disconnected. Can you still see the line?
Because you see the screen.
Okay, you just see the. Apologize. Can you see it right now? Okay. Okay. Good. Okay. So you have two relative demand in two different sectors, and the relative demand of a country is the weight average of those two. That's basically the idea. Okay, I think the mathematical equation there is some problem. This one should be here. Should be LC over KC dot KC over K bar. KS over K bar. Okay, so what happened after the trade? After the trade, for home country exporting the capital intensive goods because home country is a capital abundant country. The relative price between computer and shoe become like this. Right, so PC over PS, it's higher than autarky time. So if we go back to the relative demand and supply in the labor market, the computer sector produce more. So they will need, right? So they will need more. They will need more. They will need more capital in that sector. So that will shift the relative price of the computer demand curve from RD1 to RD2. So that will drive down the equilibrium relative wage rental ratio. So once this happened, what happened in both of the industry? The capital labor ratio, the labor capital ratio in the computer sector moved from this point to this point. And on the other hand, the labor capital ratio moves from this point to this point in the shoe sector. So in both sectors, the labor capital ratio increase. Take a look at the notes here. An increase in the relative price of a computer shifts the economic-wide relative demand for labor. RD1 toward the relative demand for labor in the computer industry. The new relative demand curve to its RD2, so blue line to red line, intersect the relative supply curve at lower relative wage. It's here. So this is exactly what I just said. So the relative wage equilibrium drop, the labor capital ratio increase in both of the sector. So what about the real wage and real rental? So what is the real rental here? The real rental means PC times MPC, right? So R is the real rental in computer sector, and this is in the shoe sector. We know that the price of the computer decrease. Well, let us just take a short break. I think it's about time. So we come back at 7:50. Okay? Could we come back at 7:50, guys? Okay, thank you. Okay, let's get back. I think I will go over the previous part on Wednesday, but right now I just want to introduce one of the very important idea of the Heckscher-Ohlin model. That's called a Stolper-Samuelson theorem. So what's this theorem tell us? Let's read through the text together. Sometimes this one is called a magnification effect. We want to know if the relative price of one of the goods, what happened to its factors, the price of the factors change. And you will see if the price of the capital intensive good increase, the rental at the capital will increase more. So in the long run, when all factors are mobile, okay, so this is one of the important assumptions in Heckscher model, an increase in the relative price of a good will increase the real earnings of the factor used intensively in the production of that good. Okay, so let's stare on this statement a little bit. What's Stolper-Samuelson theorem tell us? An increase, okay, so first of all, an increase in the relative price of a good. Okay, so here, if we have the example, is PC over PS. The price of the computer over the relative price of a computer to the price of the shoes increase, that will increase the real earnings of the factor used intensively. Okay, so what's the factor that used intensively in computer? It's the capital, exactly. Very good, thank you. Thank you, Chenxing, thank you. Thank you, David. The capital is the one used intensively on producing computers, right? So the capital, the rental on the capital will increase more. And in Hector-Link model, our rental on the capital is usually put like this, right? So we no longer need to separate R in S. Right? On the other hand, if the relative price of the capital intensive good to the labor intensive good drop, then the return of the capital will decrease even more. So for our example, the Stolper-Samuelson theorem predicts that when home opens to trade and face higher relative price of a computer, the real rental of capital in home rises and the real wage in home falls. Okay, so this is important. We will use a numerical example to give you an idea right now. Okay, so basically, this is very similar to what we've seen in specific factor model. So we all have a bunch of, sorry, I forgot to turn on my video. We all have a bunch of the conditions here, right? So in order to illustrate the Stolper-Samuelson theorem, it's just better to look at one of the example here, just like what we did in the final part of the specific factor model. So we are trying to figure out what's the goal here. If I know the price of the relative price of the computer, the relative price of the shoes increase or decrease, could I predict the change in capital, which is one of my production input, and the change of the wage, which is another production input, right? Can I predict their change? Okay, the answer is yes. Just let me show you one of the numerical example here. So once again, we are in a two-country war, right? So we are in a two-country war. So I have two countries. One is home and one is foreign. One is home, one is foreign. And then I have two sectors. One is computer, one is shoe. And obviously, computer is a relatively capital intensive sector, and shoes is relatively labor intensive sector. And then I know what? I know the sales revenue in both of the industry, in the sector. And now I'm looking at the home country. So sales revenue, here C should be a subscript. It's equal to 100. So the revenue are separated into two payments, right? The payment to the worker and the payment to the capital. So PC, PC times QC are equal to W times LC plus R times KC. Okay, so just two production inputs, so I have to pay to put two input, right? So this is my revenue and this is my cost. And in this case, it's 150/50. So in shoes industry, PS times QS, the total revenue in shoes industry is equal to 100. Earning for labor, it's 60. Earning for the capital, it's 40. Okay, so as you could see, good question, Boycott. I have to think of it. I have to think about it. Let me think about it and get back to you soon. Okay. So the goal of the Stolper-Samuelson theorem, the goal of the Stolper-Samuelson theorem is to see from the goods price and to predict the production inputs, return on the change on the production inputs return. That's it. It's very similar to what we did in the specific factor model, except for one thing, is that in the long run, the capital can still move from across each sector, and the wage will be determined by the long-term equilibrium of the capital. We'll take a look of this numerical example first. If you could pull up this one, I use a whiteboard, and then maybe it's easier for us to go over it with it. So okay, I'm flipping around from like, should I introduce more intuition, or should I just jump into the numerical model? Let's see if this will help you. Okay. So like I said, okay, Stolper-Samuelson theory. It's what we try to explain if the relative price change. What happened to the change of the rental on the capital as well as the wage to labor in the long run? Okay, so let's think about it. If home is a capital abundant country, let's go over into intuition together. Home is a capital abundant country. For example, it might be US. Okay, so a capital abundant country means what? It means, relatively speaking, it's labor scarce country. Right? So if home opens to the trade, home will export, the home country will export capital intensive goods right? This is because of what? The Hecho-Lin model, right? Because home country is a capital abundant country, so home country export capital intensive good. Okay, and the price of the capital intensive goods of capital intensive goods will go up because exporting to another country, your demand increase, and you could use your comparative advantage, so the relative price of the computer to the shoes will go up. If the shoes price stay the same, computer price will go up, right? So that makes what? The real rental on capital in home increase, right? Because they try to produce more computers in compare with the shoes, right? So if you think about shoes, just remain the same amount of the shoes they produce before and after the trade. They are just identical. And now, because open up the trade, the home would like to export the goods. They have the advantage. So they will export the capital intensive goods. And this will increase the real rental on capital goods. Rental on capital, sorry, the return of the capital will increase because you are going to uh, have more capital to help you produce more capital intensive good. And on the other hand, real wage will decrease in home. So that's the intuition of the Stolper-Samuelson theory. So I should give you an example, maybe next time, give you an example to explain the whole process. But that's the mechanism behind the Stolper-Samuelson theory. Starting from the actual link, the prediction of the actual link, and the return on the factors. Okay, so if we take a look of the numerical example, this might become clear. I hope so. So, like we have here, the revenue in computer sector, and this it's equal to the payment to the capital plus the payment payment to the labor in computer sector. Right? And in the book, it tells us this is 50. This is 50. And in shoes industry, the sales revenue is also equal to 100. But because shoes is relative labor intensive, so PSQS Okay, so you note that the shoe industry is relatively labor intensive. So if we assume that after the trade, the price of the computer increased by 10%, while the price of the shoes remained the same. So what does this mean? This means the relative price of the computer over the shoes increased after the trade, right? And the Stolper-Samuelson theory tells us what? This increase will cause the rental on the factor increase more than this. So R will increase a lot, while wage will decrease a lot in home country. So this is the result I would like to show you right now by giving a numerical example here. Okay? So then we just go over the similar process than what we did a specific factor model. So R in the computer industry, if you do a simple algebra here, what will you get? R is equal to the total revenue, total sales, total revenue of this industry minus payment to another production factor divided by the capital you use in this industry, right? So in shoe sector, it's also the same. Okay, what's the difference between an actual model and a specific factor model? The only difference is right now the subscript is gone. And that is because of what? That is because the two capital right now, they can move across the industry, right? So we need to figure out this term. And then to set another equilibrium condition for those two terms, then we could figure out the change in the equilibrium wage and a change in the equilibrium rental on the capital. Let's see how we do it. So first of all, let's see this equation. We try to find out this on this in the computer sector, right? So if you have a delta here, means you look at the change in price for each of the term. Okay? Basically, we use the similar logic in the specific factor model. So now I have a delta here, I have a delta here, all in the price term. But I divided R in the denominator in the left-hand side. So I need to divide R in right-hand side as well. And what is the next step? Use the algebra trick, right? I don't have the exact number of the price change in computer, but I have what? I have this. So what should I do? I divide it and times another one in the numerator, right? So this term and this term should be identical. Next, by doing the same trick, this is what I get, right? So do I have the number of this? That's equal to, what's the change in percentage of the pricing computer? 10, exactly. What is the total revenue in the computer sector? 100, right? And this is something I want to figure out, so I just leave it here. What about this term? W times LC, it's equal to 50, very good. And R times R at KC, it's equal to what? 50. Yes. So now I will have just organize this equation. 10 minus 50 over 50 over, right? Right? In a specific factor model, this one is given. The relative, the change, the percentage change in a wage is given. But since we are in a long-term setting right now, this becomes something we want to figure out. So hold on a second. Where is my another equation coming from? Now I have the change, the percentage change in capital, the return on the capital on computer sector. I need to figure out this one as well, right? So I need to figure out this one as well. So this one will be a function of this too. So after I figure out this one, combined with this one, I can figure out the equilibrium change of the wage. That's the idea. So until now, it's exactly the same trick and the calculation in a specific factor model. Everything we use here, we learned it on last Wednesday. And we need to do it one more time in this equation, and then to put those two together to find out W. That's the process. That's the logic. What I'm doing right now. So let's take a look of the equation 2. Could I erase the note right now? Okay, thank you. So R, let's see. R right now, the return, the rental on the capital in the shoe industry, it's equal to PS times QS minus W times LS divided by RS. Sorry, KS. My notation should be like this. All right, so once again, delta R over R, it's equal to right? A small trick on the algebra. Okay, so then just plug in a number. What is this one? This we basically, in the beginning, we assume this is equal to 0, means the price of the shoes does not change. Right? We assume this change, right? So now I have this, it's larger than 0, so I could have this just equal to 0. Okay, and this, it's equal to what? 100. This is something I'm interested in. This, because shoes is a labor-intensive industry. So shoes, the payment to labor in shoe industry is equal to 60. And R times KS, the payment to the capital in shoe industry is equal to 40. Right? So now in shoes, the change percentage of the capital, the rental on the capital in shoes industry is equal to what? It's equal to negative change in wage percentage times 60 divided by 40. Okay, so this is my another equation. This is from shoe sector. And from the computer sector, I already calculated out which one. I already calculated out the equation. That's equal to that's equal to 10% times 100 over 50 minus change in wage times this, right? So this is in the computer sector. This is in the shoe sector. So if it's in a specific factor model, remember what do we do? If it's in a specific factor model, we just give this one a subscript. Like this. And then we given the wage change. Right? And then you could calculate out the number of this, the number of this, and to compare with the price change. But this is not the case in a long-term model. In long-term model, in a Heckscher-Ohlin model, we need to do one more thing, is to set the two terms equal to each other. Or you could use the idea in a book to subtract each of the change. So this is actually the long-term equilibrium condition. If we apply this and apply this together, we could find out the change of percentage of the wage is equal to something. Right? So let's do it. Let's do it. So the two equations I have in shoe industry. Can I erase right now? Not so many response. Okay. Okay, so two equation I have right now. Okay, let me just rewrite it again. Two equation I have right now in shoe in PC is in shoe industry. Right? Equilibrium condition. So we will get what? We will get 10% times equal to 0. 0 times something is equal to 0 minus this. Right? So this turn out to be equal to 2. This one becomes 1. So 20% minus this is equal to negative times 1.5. Right? This is going to be this. 0.5. So last step, algebra 0.5. It's negative. So the wage change will become negative 40. So you see, if you compare with the original condition we have this, we have this. Now we figure out the change in percentage in the wage is equal to negative 40%. What about R? What about the rental value capital change? You could simply plug this term back to either of them. Right? It seems to be it's easier to plug in this. So this delta R over R, the change in the rentals on capital, it's equal to negative that will equal to negative 40 times 1.5. Oh, negative here, so negative here become positive. Okay, so this is what you get. You started from the price change, and you figure out the factor's price change. And that's basically the Stolper-Samuelson theory. If the price in the capital-intensive good increase more than the labor-intensive goods price, the price of the capital, right? Because capital intensive goods use capital more, will increase more than the price change. On the other hand, the other factor that didn't use in the use less in the capital intensive goods, the price of that factor will decrease. So in this case, because US exports PC, the capital owner in the US, so capital owner, you could see like a bank or like the factories that produce PC, their return will increase much more than the simply price increase. On the other hand, because PC is a computer is a capital intensive good, the labor did not benefit. The wage of the labor decreased a lot. Okay, so if you put it to the inequality that we have, what do we get? We get delta PC. That's it. So this actually showed you the Stolper Samuelson theorem, the magnification effect. So if you go back, take a step back a little bit, there's nothing different from the derivation that we have in the specific factor model. The only difference is what? The only difference is right now the capital in two different sectors are same right now in the Heckscher-Ohlin model. In the long run, capital can move. They can sell their machine in shoe industry in return to buy another machine in the computer industry. And it's the same thing if you cash out your equipment right now. In the long run, you should be able to move to another sector. So this is the main differences in the specific factor model that we discussed in the chapter 3 and the Heckscher-Ohlin model that we discussed in chapter 4. One is in the relatively short-term perspective, and one is in a relatively long-term perspective. So what's the difference in the numerical example? The only difference is the specific model ended here, right? And you could just simply order all the price vector change a single inequality. But in the Heckscher-Ohlin model, you need to do one more thing, is to set these two terms equal to each other, or to set these two terms subtract each other equal to 0. Because in the long run, that's something we call equilibrium. Right? If you have a supply, if you have a demand, how do you find out the equilibrium? You subtract it, or you plug in one of the equation to another one, so that you could figure out the equilibrium price or equilibrium quantity. We are doing exactly the same thing here. Due to the capital is movable in the long run, right? Capital is movable across the industry by the assumption of the Heckscher-Ohlin model. So we could figure out the equilibrium of the labor wage, the change in the labor wage, so that we could figure out what exactly is the percentage change in the capital as well. So that we could show, due to the price change, the factor's price will change, and the factor's price will change much larger than the price of the goods change. That's basically Stolper-Samuelson theorem. Is this too complicated? I just want some of the feedback. Is this okay, or this is straightforward, or is it too slow, or this totally makes sense, totally doesn't make sense? But at least you need to know, okay, I got two responses. Say it's very complicated. Okay, hard. Okay. But at least you need to know what's the meaning, what's the definition of the Stolper-Samuelson theorem. Because when you walk out of the classroom, people ask you, have you ever learned about a Heckscher-Ohlin model in your international economics course? If you say yes, people will ask you, talk about the Stolper-Samuelson theorem. This is something you have to know. Either it's through the intuition or it's through the numerical example. Think about it, and let me know if you have any question. Okay, my original plan today is actually try to get into chapter 5, but I don't really think that we will have the time to discuss about the migration FDI right now. Does anybody already do some of the readings in chapter 5? Okay, yeah, okay. Some of it, yes. Okay, so yeah, but I do want to cover a little bit of the chapter 8. So on Wednesday, I will extract some of the idea from chapter 5 and some of the idea in chapter 8. For chapter 5, we will only focus on the migration and the FDI and the box graph. And in chapter 8, we probably will only discuss one or two of the graph in the book, at least to let you guys know what happened if the government imposed the tariff, or what happened when government imposed some of the trade policy. Hopefully, I could, like cover it on Wednesday night. But take a look of the Stolper-Samuelson theory and completely review the Heckscher-Ohlin theory. I think Ricardian specific model and the Heckscher-Ohlin theory, this three big model will be the main part in our midterm. Okay, so I guess I'll open the floor to the question right now. If you don't have a question, thank you for participating in today's lecture, and I will see you on the Wednesday night. If you have a question, feel free to just shout it out, or just use the chat room to let me know. So I got a question. Review Ricardian specific HO, correct? That's correct, and basically that's the main part of the exam, right? So do your homework assignment by yourself. Do additional questions and compare it with the answer key. And if you have a time, go over the lecture slides. I think that will be enough. Okay. Thank you.